To the Curious Calculator. In today's episode, we're going to be going over probability of disjoint and overlapping events. So let's dive in here. Let's consider the following diagrams. So let's see here. The first one over here, the shaded region is showing us the union of events A and B. In this middle one, the shaded region here is showing us the intersection of events A and B. And in this last one over here, we're seeing the union of events A and B with the shaded regions here. So let's go into this a little bit more. The union of two events, as we can see here in the first diagram with the shaded region, is the the outcomes from event A, the outcomes from event B, and the outcomes that are shared by both event A and event B, shown here. And I try to color code this so that we see that the outcomes from event A are blue, the outcomes from event B are yellow. And because when you mix blue and yellow together, you get green, I put the outcomes that are shared by both events A and B to be green here. Alright, so let's look at the next one where we see the intersection of the two events. The intersection is only the outcomes that are shared by both event A and event B. And then the union we see here is the outcomes that are from event A and the outcomes that are from event B. So let's notice here that both of these are unions, this one here and this one. But the difference here is that with this case, the first case, there is an intersection of the two events, meaning that there are some outcomes that are shared by both events. And when that is the case, the union includes that intersection. But as we can see here in the last one, there are no outcomes that are shared by both events, so we really can't include any intersection there with that union. Alright, so let's note here that whenever we are considering the union of two events, we do that when we're calculating the probability of A or B. And when we consider the intersection only of two events, like this case here, we are doing that when we're trying to find the probability of A and B. And then in this last case here, again, we're looking at the union of the two events. So we do that when we're trying to find the probability of A or B. And then one further thing to notice here is that these two here are what we would consider overlapping events, meaning that there are some outcomes that are shared both by event A and event B. And this one right here, the last one, this is going to be disjoint. So these are disjoint events, meaning that there are no outcomes shared by both event A and event B. Okay, so let's see here. Let's now define a compound event. A compound event is the intersection or union of two events. So looking back up here, we can see that the shaded regions here, if we think of the shaded region as a third event, like a compound event, so let's say that the shaded region is the compound event in each case. Compound event in each case. Okay, so if we do that, then we can see here that for each of these, we have a compound event that is, well, depending on which case we're looking at, it's either going to be the intersection or union. So this first one, the compound event, is looking at the union of events A and B. This middle one, this compound event, is looking at the intersection of events A and B. And this last compound event here is looking at the union of events A and B. Okay, so let's look at a little example here and also look at how we can write the probability of compound events in symbolized form. And one thing I would like to point out here actually is that it kind of bothers me a little bit in the textbooks that they teach it in this way, that when you see probability of compound events, they typically give you the probability formula for calculating the probability of A or B, but we should keep in mind how we just noted above that a compound event is the intersection or union of two events. And like in the middle case here, where the shaded region is a compound event looking at the intersection of A and B, and we use that to calculate the probability of A and B. So technically, the probability or finding the probability of A and B is also a probability of a compound event. It is just not typically taught in that way. Typically, when we hear probability of compound events, we think probability of A or B. Okay, so let's look at this now. The probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Alright, so let's look at an example here. Let's say that we're going to draw a ball. And when I say draw a ball, I'm talking about drawing a ball from this jar we have over here on the right. And this jar over here contains 5 balls that are blue, 5 balls that are orange, and each of the blue ones are are labeled 1 through 5. So we see 1, 2, 3, 4, 5, and then each of the orange ones are also labeled 1, 2, 3, 4, and 5. And so we're going to draw a ball, and let's say that event A is drawing an even number, and event B is drawing an orange one. Alright, so we can draw a little Venn diagram here to see how this might look. We have event A, we have event B, or actually I'm going to do this, I'm going to color code this to make it a little bit more clear. So let's do this. Let's do this. And let's say this is event A, this is event B. And for this one, I'm going to say event A is the even number. And so let's see here. I'm going to say that the even number, well, we have, okay, well, event A, let's say we have 2 and 4. And then let's see, so even numbers, we have 2, 4, and then we also have the orange even numbers, 2 and 4. And so let's see here. For that one, because they're even numbers and they're orange, I'm going to go ahead and put that in the intersection here where the outcomes are shared by both event A and B. So we have the orange, well, that didn't come out right. All right, so 2 and 4. So we have those ones. So that's going to be all the even numbers. And notice how that is included in both the circle for event A and is included in this little region here that is overlapping. All right, so now I'm going to do event B, which is the orange ones. And well, we already have the orange ones here that are 2 and 4. So I just need to fill in 1, 3, and 5. Alright, so now we have our Venn diagram, and now we can start calculating some of these probabilities. So, the probability of A will equal, well, in A we got to include everything that is included in the circle of A. So we have 1, 2, 3, 4 favorable outcomes. 2, well, there are 10 balls total in the jar, so that's 10 possible outcomes. All right, so now we're going to look at the probability of B. And the probability of B equals, well, all of the outcomes that are included in B. So we have 1, 2, 3, 4, 5. 5 favorable outcomes out of the 10 possible outcomes. And then the probability of A and B. So probability of A and B. And that is going to equal the outcomes that are in this shared region here between events A and B. So that's there are 2 options here, 2 favorable outcomes out of our 10 possible outcomes. This means that when we calculate the P, A, or B, the probability of A or B, that's going to equal 4/10 plus 5/10 minus 2/10, which equals 4 plus 5 is 9, minus 2, 7/10, which equals 0.7. Awesome. So that right there is going to be our probability of drawing an even number or an orange ball. All right, so right now I want to kind of compare and contrast this with what I have right here below. Let's take a look here. So let's note that if A and B are disjoint events, then the probability of A and B equals 0. Therefore, the probability of compound disjoint events is the following. The probability of A or B equals the probability of A plus the probability of B. And notice that we're saying that is the case because the probability of A and B equals 0, which is this part shown right here. And if that's 0, then all we have is just the probability of A plus the probability of B, which is shown here. And remember that the disjoint events are the events that look like so, where there are no outcomes shared by both event A and event B. All right, so let's look at calculating the probability of one of these examples here. Zoom out a little bit. Okay. For this one, let's consider that we draw a ball, and event A is going to be drawing a blue odd, and event B will be drawing an orange ball. Okay, so let's draw a little Venn diagrams here. So A, B, and then inside of them, let's see, a blue odd. So that's going to be 1, 3, and 5. And then an orange, let's see, an orange one, well, that's going to be 1, 2, 3, 4, and 5. Okay, and we can notice here that there are no events that are included in both event A and event B, and therefore they are disjoint. So calculating the probability, we just need to do probability of A plus the probability of B. What is the probability of A? Well, the probability of A equals the number of favorable outcomes here, which there are 3 over the total possible outcomes. And then the probability of B equals the number of favorable outcomes shown here, which there are 5 over the total possible number of outcomes, which is again 10 because we have 10 balls in the jar. And so now when we calculate the probability of A or B, that will equal 3/10 plus 5/10, which equals 8/10, which is 0.8. And that will be our final answer, and that will wrap up today's video. I'd like to end today's video, as always, with a little fun philosophy fact. Did you know that the philosopher Aristotle tutored Alexander the Great when Alexander was just a teenager?